Hi, I'd like to introduce myself. I'm Martin Jewell from Evo3D. I am the R&D Director. So I'm proud to show our new pellet extruder. So our pellet extruder is a Rapid Fusion PE320, and the extruder itself is what we've aimed to do is ensure that we can have an extruder which has an exceptional power to weight ratio. So what we're looking at is an extruder with a weight of 22 kilograms. And the reason why we've gone for that weight is so it fits within the KR22 range to save some money in terms of not being able to, ensuring you don't have to have a large robot, so you can keep the power to weight ratio as compact as possible. And then also what we've this enables is it enables you to upgrade existing CNC machines to then make them capable of becoming 3D printers. So from the top then, the extruder has a 1 kilowatt motor and a 1 in 25 gearbox. Also we have 4 heating zones. These heating zones, they go up to 500 degrees each, which enables you to print high-end engineering grade material. Also from the bottom we have a selection of nozzles. The nozzles range from 3 to 12 millimeters, and we have a selection of different types as well. So we have some which enable us to iron the material so we can ensure a perfect next layer adhesion, and also we have other nozzles which are multi-planar. That means that when the extruder is connected to a robot and you're now printing at a 33 or 35 degree angle, the previous layer doesn't get destroyed by the nozzle edge. So just talking through other sort of main features of this extruder, we have a pellet feeding system. So this pellet feeding system has an integrated sensor which enables us to connect to our custom made control console. So basically what that means is that there's always pellet on demand. So the extruder knows when it needs pellet and it will self-feed. And it has a nice little viewing chamber here. And what this enables you to do is at a glance see that there's material, and you can see that you're sort of good to go. The system also has an alarm as well, the control console. So if it demands pellets and no pellet arrives, you'll get a notification that enables you to check your pellet feeding system, ensure you've got material in your hopper or your dryer. And because of the reservoir here, you can still continue to print for maybe 5 to 10 minutes depending on your flow rate to ensure that we can not abandon prints essentially. Also the speed of the extruder, so we're aiming for 12 kilograms per hour. So 12 kilograms per hour on a 22 kilogram payload is exceptional, and we believe that is best in class. Also we have an integrated air cooling system. So this is fed by compressed air, also controlled by our control panel. And what that enables us to do is we can control air via the slicing software. So whether that be a Daxis or AI build, we could say on layer 2 for example, we want some air cooling to ensure the parts can be cooled. And also what we can do is we can adjust this to ensure that we have it in the perfect position every single time. The HMI control console also has a toggle on and off. What that means is if you forget to put part cooling on, or you're doing some experiments with new material and you think, you know what, I can do a bit of part cooling, you can just toggle that on, right on the control console, and again, saving wasted time and wasted material. So also the additional features is that the barrel is also cooled. What that enables us to do is it keeps the fluctuations of temperature to a minimum, and also if we're printing low temperature materials and there's a lot of heat generated by friction, we can actually cool that barrel to make sure it's the perfect temperature for your printing applications. So in terms of our partners, so we've also partnered with a number of material experts for AirTech, Reflow, just to name a few. And what that enables us to do is on our control console, we have a material library. So we can select a certain material on HMI, and that will preheat all the zones ready to ensure that you're going to be printing at the perfect temperature for that material with our extruder. So everything will come predefined. And then in terms of safety, Our control console integrates seamlessly with the KUKA robot and also seamlessly with CNC machines. What that enables us to do is, for example, if you were to hit the emergency stop on the KUKA, the control console would shut down, all the heating zones would go to 0, and the motor would stop extruding. And the flip of that, if you were to hit the emergency stop on the control console, the robot would shut down. And it also covers us for safe shutdowns and sort of, I guess, non-emergency stops as well. So just to ensure that there's never going to be a moment where you're extruding and without the barrel being at the correct temperature. Just to touch on the barrel being at the correct temperature, also what we are able to do is we call macro programs within our console. So the KUKA, for example, would say, okay, control console, are the heaters at temperature? Do they have an error? And are we good to go? Are we safe to extrude? And once those questions are answered, the robot program will then continue. What that means is that we're never going to be extruding with a closed barrel, and also if there is an error for any reason, one of the heaters throughout the printer process, again, the robot will stop, extrusion will stop, and that ensures we have a safe, robust system. I think that concludes the main specs and configurations of the Rapid Fusion Pellet Extruder. And in the next couple of weeks we'll be doing some vigorous testing, and we look forward to sharing more information with you guys. Thank you.